Yes, good morning, my friends. I hope you all are doing good. Yes, Shekhar, good morning. How are you? How are you doing? I hope you are doing good. How is your preparation? Okay. Today also we will continue with the discussion that we have been doing. So today we will look at continental drift theory of Alfred Wegener. Okay, this is a very important theory. We will see that today. But before going any further, in Unacademy platform we have this special prize week. Only one day left from 10 to 17 November. Only one day left. You can use my code, that is SUNEP 10, in order to avail 10% of discount. The course is for 1 year, 2 year, 3 year, depending on your plan. Okay, the course is either plus combo or iconic combo. Clear? Now, you also have this free test series in the Unacademy platform. The free test series is composed of 3 sections. One is the Abhiyan, that is the static part, every day from Monday to Friday, 10 a.m. You have this current affairs part, that is also 15 MCQ in 15 minutes, Monday to Friday at 7:30 p.m. Okay. Also, you have every Sunday, you have this Unacademy compact. Clear? Chalo. You have this loans for UPSC. Okay. One important characteristic is it is zero processing fee. Okay. Approval at less than 2 hours. Also, if you are aware, well and good, and kindly share the information with your friends and families, so that no one should be left behind for the financial factor, okay, in order to prepare for this particular exam. Clear? Chalo, let us begin our today's discussion. I hope my audio and video is working fine. Clear? In the middle of discussion, if any of you, if you have any doubt regarding any points, you can interrupt me at any point of time. Okay? You can interrupt me at any point of time. You can just put a comment in the live chat box below. Okay? So you can interrupt me at any time. Shall we continue? Yeah? Shekhar, I hope you are there. Clear? If you have any doubt regarding any portion, you can always go ahead and ask me. Before going into the session, I don't know whether you know or not, I have a Telegram channel by the name of All About Geography. Okay? The invite link will be t.me/SUNEP10. Okay? I share all my upcoming classes, lectures here in this particular Telegram channel. Okay? Anyways, let us begin the discussion. See, there was one gentleman by the name of Alfred Wegener. In the period around 1912 to 1915, he proposed one particular theory. And the name of that theory is continental drift theory. Now, what is this continental drift theory? Okay, continental drift theory. What is this continental drift theory? Clear? Now, Alfred Wegener was a climatologist. Climatologist means he wanted to examine, or he wanted to study the paleoclimate. Paleoclimate in a sense, okay, paleoclimate in a sense, the climate of the past. The earth is somewhere around 4.6 billion years old. Therefore, he wanted to study how different type of climate changes took place in the earth's history. Now, during his study of the paleoclimate, he came across in today's earth's location, in today's different continent, okay, in today's different continent location. Say for example, this is earth, this is equator, this is temperate latitude. Now in this cool middle latitude, he found lot of, or huge deposit of coal. Huge deposit of this coal. Now, what is this particular coal? Coal is nothing but the decay of vegetation. Decay of vegetation is nothing but the coal. Now, as per the today's climatic condition, the coal formation is usually in the tropical and equatorial region. Why? Because for the formation of huge amount of coal reserve, you need huge amount of or large vegetation. Large and very lush vegetation you need to have in order for a huge coal deposit to come about. Now, as you know, vegetation depends on the climatic conditions. Now, more vegetations, larger vegetations will happen in a place where moisture and temperature is sufficient. Now, in the equatorial region or in the tropical region, you have sufficient amount of moisture and temperature. Therefore, in today's context, most of the coal will happen near around equator or tropical region. But during Alfred Wegener study of paleoclimate, he came across even in a very cool temperate latitude where actually large number of vegetation is not possible, there was a presence of huge amount of coal reserve. So, it was a little bit of a puzzle. Why in a place where huge vegetation is not there, how come this particular coal is found? Now, in order to explain this, there is only two possibilities. One possibility is, say for example, this is earth, this is sun. Okay, I have a sun. Now, in the geological past, it may be so that the sun insolation in today's context, if we just take the general, we know there is an apparent shifting of the sun rays like summer solstice, winter solstice, but all in all we can assume that the sun is directly perpendicular to the equatorial region. If we just assume like that, the one possibility of explanation for the presence of huge amount of coal in the cool temperate latitude is in the geological past, who knows, the sun's location would have been in a different condition, which means the sun was directly over the today's cool middle latitude. That is one explanation. The other explanation was the sun location remains fixed as it is today, but the continents which is here in the earth, the continents would have shifted the position from one region to the other. So that was the second explanation. Okay, so broadly there are two possible explanations. One explanation is that the sun ray or the sun's location was different in the geological past, different in a sense like today the sun is over the equator. In the earlier geological times, the sun would have been near the cool middle latitude. Thereby, when the sun's position is over the cool middle latitude in the geological past, this region would have similar climatic condition like today in the equatorial region. Therefore, in the cool middle latitude, lot of vegetations will happen and the decay of that vegetation will turn into coal. So that was one explanation. The other explanation was the sun location remains fixed, the relative position of the earth and sun is fixed, but the continents, the today's cool middle latitude in the geological past was situated near the equator. Okay, near the equator, and since it is near the equator, it is experiencing a very humid and warm temperature, thereby a lot of vegetations, and because of that presence of formation of coal. After the formation of coal, this particular location shifted or migrated to today's position in the cool middle latitude. That was the second explanation. Now, under these two explanations, which one do you think is more feasible? See, as far as the relative location of the sun and earth is concerned, they are almost fixed. So, changes of the relative position of sun and earth is quite unlikely. Therefore, the first explanation is completely ignored. Therefore, Alfred Wegener went for the second explanation. In the second explanation, it is, I repeat once again, in the geological past, today's cool middle latitude, this continent was near the equator. Thereby, since this region is located near the equator, it has got sufficient amount of vegetation Because of that, after decay of this vegetation, the col was formed. After the formation of this col, this particular continent was shifted to the cool middle latitude, which is as of today. Okay, Dixit, good morning and welcome to the session. Okay, so the second explanation for the presence of huge amount of coal in cool temperate or cool middle latitude gave rise to the theory of continental drift theory. Clear? Understood? Any doubt? I repeat once again, Alfred Wegener was a climatologist. He came forward in 1912 to 1915 a theory known as continental drift theory. Now, see, he was a climatologist. He wanted to study the past climate. During his study of the past climate, he observed there is a huge amount of coal in the cool middle latitude. Now, coal is what? Coal is nothing but the decay of vegetations. In cool middle latitude, huge vegetation does not occur. Then how this coal is formed? In order to explain this, he came to a conclusion that today's cool middle latitude, the continent which is there in the geological past, it was near the equatorial region, thereby having huge vegetations, thereby explaining the formation of coal. But this finally drifted apart or moved to a cool middle latitude, and that is how he is able to explain the occurrence of coal in cool middle latitude. Clear? Oh, thank you so much. Okay, therefore his main postulates were, Alfred Wegener considered that the entire earth, the entire continent, we have different continents, North America, South America, Europe, Africa, Australia, Eurasia, everything was clubbed together or formed together in one particular place, forming a supercontinent known by the name of Pangaea. And this supercontinent, which is known as Pangaea, is surrounded by water in all the direction. And that particular surrounding of the water is known as Pandalasa. And this Pandalasa, the water body, is nothing but the primeval Pacific Ocean. Now this particular Pangaea, the supercontinent, before the breaking up of the continent, okay, it is broadly divided into two. Gondwana land, that is the southern part, that is consists of today's Australia, Antarctica, peninsular India, Africa, South America. The northern part consists of known as Laurasia, consists of North America, Europe, Asia. Okay, and these two broad region, that is the Gondwana land and the Laurasia, was separated by a inland sea, a very shallow inland sea known as the Sea of Tethys. So this is the basis, the foundation on which he put forward the theory of continental drift theory. Clear? Now let us see the important aspects of this continental drift theory. Now during our discussion in our earlier session, we have already seen the geological timeline. In this geological timeline, we have seen different era, different period, different epoch, so on and so forth. There we have already seen what is Carboniferous period. Now, the breaking up of the continent took place in this Carboniferous period. Now you kindly observe this diagram. In the earlier times, in the geological past, the continent of the world, okay, the continent of the world was like this, forming a supercontinent known by the name of Pangaea. The northern side is Eurasia, North America, so on and so forth. In the southern side, it is the Africa, the Indian plate, the Antarctica, the Australia, South America, surrounded by a water body known as Pandalasa. The closing down of this Pandalasa finally resulted into the Pacific Ocean of today. Okay, that's why it is known as a primeval Pacific Ocean. Clear? Now, you see here, now, drifting of the continent. Okay, drifting of the continent, this one. From this initial condition, drifting of the continent in different direction can be broadly classified into two. One is drifting towards the north. One is drifting towards the south. So the direction of the movement of different continent can be summarized into two directions. One is towards the north, one is towards the south. One is towards the north, one is towards the west. You see here, Indian plate. Kindly follow the pointer. This is Indian plate. This India plate moved towards the north. African plate, this also moved towards the north. On the other hand, North America, this moved towards the west. This South America, it also moved towards the west. So the entire movement broadly, okay, I am telling you broadly classified into northward movement and westward movement. Now you see here, Earth as a whole, Earth as a whole is a sphere. Now, important characteristics of sphere is it has got maximum mass, okay, maximum mass in the center, that is in the equatorial region. Okay, by virtue of the shape of a sphere, maximum mass in a sphere is in the center, that is in the equatorial region. Minimum in the polar region. Okay, now you also know what is the force of gravity. Gravitational force F equal to some constant from our basic school days, m1, that is the mass, m2 divided by r square. This is the basic gravitational force, which means can I write that force, that is gravitational force, is directly proportional to the mass, which means in the equatorial region, in this region, by virtue of being the maximum mass, the gravitational attraction will be more from this equatorial region. Because of more force in this equatorial region, this particular India or Africa, they are attracted towards this equatorial region. That's why this Africa and India migrated or shifted towards the north in this direction. That is the explanation given by Alfred Wegener. That is, for the northward movement of the continent, the force required or the force by which it was migrated, okay, or the shifting of the continent towards the north, the force responsible is because of the equatorial bulge and exertion of extra gravitational force. Clear? That explanation was given by Alfred Wegener. Clear? Is it clear? Now, that is one. The second type of motion, that is the westward movement of the continent is, what is the force responsible? The force responsible is the tidal force, which means you have this tides, okay, tides in a sense, you have this oceanic tide, okay. Now, oceanic tide occurs because of the gravitational attraction of sun and moon. Now, because of this, what happened? In the water body, a tide is generated. Once this tide is generated, you all know Earth has got two motion. That is, one, it revolves around the sun. The other one is the Earth rotates around its own axis. Now, when the Earth rotates around its axis from west to east in this direction, if a tide is generated, this tide when seems to relatively move towards the west, okay, like this. I hope you are understanding. Because of gravitational attraction of the sun and moon, a tide is generated, means the water body is attracted, like this. You will find, I will show you. No, it's not here, but still, because of gravitational attraction of the sun and moon, a tide is generated on the water body of the earth. Okay, water body of the earth. When that particular tide is generated, you know that the earth revolves around its own axis from west to east, which means this tide which is generated, relatively it seems to be traveling towards the west. During its journey to the west, you see here, such it comes in contact with this. It comes in contact with the landmass. Kindly follow the pointer. It comes in contact with the landmass. The landmass is providing resistance. During the process of providing resistance, this tide is pushing this particular landmass towards the west. And that is how the North America and South America is drifted towards the west. This explanation is given by Alfred Wegener. Clear? So, the present continent that we have, say for example, this one. Kindly follow the pointer. This is our present continent. You have this North America, South America, Africa, Eurasia, Indian plate is here. Now, earlier it was like this, consisting of one single huge mass of land known by the name of Pangaea or supercontinent. Slowly breaking up occurred. Okay, this Indian plate, you can see it is moving towards the north. Okay, this South America, North America moving towards the west, and finally resulting into the present location of different continent. This theory is known as continental drift theory of Alfred Wegener. Clear? See, we will go and see one by one. Okay, you kindly follow the diagram which is in front of you. Okay, you see here Eurasia, India is here somewhere. Kindly follow the pointer. North America is here, South America is here, Africa is here, Antarctica is here, Australia is here. Now it gradually gives rise into, you see here, now breaking up occurred already. Indian plate is separated from the supercontinent. Africa also got separated. North America, South America. Okay, see, North America, you kindly follow the pointer, very important. This North America was sharing with this Eurasia in this region. It was sharing together. It was part and parcel of the same landmass. Keep this in mind, very important. Why? Because we are going to see the evidence. During that time it will be very important. This North America, okay, you can find Appalachian mountains. In today's North America, on the northeast side, you will find these Appalachian mountains. Now this is in connection with the landmass of Eurasia, that is the Western Europe, that is the present Ireland, okay, Ireland, United Kingdom and all. The South America is completely joined with the Africa like this. Okay, you see here, now it has been broken. Division is taking place. Gradually Atlantic Ocean is opening up here. Indian plate is detached from the supercontinent. Now come here, Indian plate has moved further towards the north. African plate is also moving further towards the north. North America shifted west, South America shifted west, enlarging the Atlantic Ocean region here. Clear? Finally it will result in this nature. You see here, this is how the today's location of the continent. Clear? Now what are the evidence? Okay, I hope you understood what is continental drift theory. Any doubt? You can interrupt me at any time if you have any doubt. Okay, our sole aim is to understand, okay, and to clear the exam. Anyways, what are the evidence? What are the evidence in support of this continental drift theory of Alfred Wegener? Now the first one is geographical similarity between the opposing coasts of Atlantic Ocean. That is just like a jigsaw fit. Okay, jigsaw fit, which means suppose if I bring this South America, North America, or if I close up this Atlantic Ocean, this completely fits with each other. This is one of the evidence. Why? Because you see here, in the South America, you have this bulging at this. On the African continent, you have this groove here. So when I bring this South America, or if I close down this Atlantic Ocean, this region completely fits on this. So a perfect fit. So it suggests, or this is in support of the continental drift theory. So this is one of the evidence of continental drift theory, that is geographical similarity between the opposing coasts. The second important evidence in support of continental drift theory is similarity in the geological structure. What do you mean by this? Structure and rock orientation, geological similarity. You see here, structure and rock orientation of North America and Ireland, they are almost the same. you come to this diagram. See, I have already mentioned to you, before the breaking up of the continent, they are together now. The mountain forming before this continental drift took place, say for example, if I have an Appalachian mountain here in the northeast of North America, okay, now if in today's context, if I go and see the Appalachian mountain which you have in the northeast of North America, it abruptly ends in the water body. But if you again go to the Europe, especially in the Ireland region, you will find abruptly a mountain ranges, and these mountain ranges are very old mountain system. Okay, very old fall mountain system. We have already seen what is fall mountain system. Under this fall mountain, we have seen what are young fall mountains, which one are old fall mountains, we have already seen. So in today's continent, location of the continent, if you go and see, in this Appalachian mountain which you will find in the northeast of North America, it abruptly ends in the Atlantic Ocean. But on the other hand, if you go to the Ireland, that is the opposite side of the Atlantic Ocean, then you will find a continuation of this Appalachian mountain in the Ireland. So this suggests, and the orientation also, in the North American region, okay, in today's North American region, here, in today's North American region, kindly follow the pointer, the Appalachian mountain is oriented in this direction. That is from southwest to northeast, like this. Okay, southwest to northeast like this. If you go to Europe, especially in the Ireland, you will find a mountain system in Ireland. These are the all fall mountain, which is having the same orientation. This is also from southwest to northeast. This acts as a very important geological structure similarity in evidence or in support of this continental drift theory. Because such kind of orientation and the presence of a mountain ranges on two sides of the Atlantic Ocean can be explained only by the process that in the geological past these two locations were joined together. But it has been broken because of the continental drift theory. Clear? Therefore, another evidence is the similarity in geological structure. Example, structure and rock orientation in North America and Ireland, they are quite similar if you bring together. Now, the third evidence in support of continental drift theory is distribution of Permo-Carboniferous glaciation. The deposits, you kindly see this figure. Okay, here, you see here. In the earlier or in the geological past, since as per the continental drift theory of Alfred Wegener, we know that all the continents were combined together forming a supercontinent or Pangaea. If there is any glaciation in any geological period, since all of these continents were together, the glacial deposit will be there. Okay, even animals, see, you see here, animals, presence of trees or plants, or deposition of glaciation period, okay, glaciation period, thereby giving rise to glacial deposit. All of this is a function of temperature and is a function of, you can say, climatic factor. Now we know climatic factor as per different latitude, okay, as per different latitude varies. Climatic condition in the equator is different, climatic condition in the polar region is different, climatic condition in the temperate region is different. Thereby, the deposits of plants, deposit or glaciation, they will all happen as per the different latitude. Now, since all of this continent forming a supercontinent or Pangaea located in the same place, the deposits, be it a glacial deposit or be it the presence of animals, same type of animal, you see here. This is Earth, okay, this is Earth, this is equator, this is a polar location, North Pole, this is South Pole, okay. Now, if you go and examine, the vegetation also varies as per the latitude. In the equatorial region, there will be different type of plants and animals. In the polar location, in the temperate location, temperature, precipitation, they are different. Okay, now depending on this, if you have certain type of plants and animals, after they die, they decay, the deposit that you will find will also correspond to these particular climatic conditions. In the geological past, since all the continents were clubbed together forming a supercontinent, they were located in one place itself. Therefore, plants, animals, everything will be similar. Therefore, after it got decay, the deposit that you will find will also be similar, be it a glaciation. Say for example here, fossil evidence of the Triassic land reptiles. Now since this organism stayed in this particular region, you will find these deposits in India, in Antarctica, in Africa. Similarly, deposit of this nature like the fossil of this Clocepterus found in all of the southern continent, you will find in South America also, in Africa also, in Antarctica also, in Australia also. Now, in today's position of the different continent, if you try to justify, you will not be able to justify. Why? Because South America is in different climatic condition, Africa is in different climatic condition, Antarctica is entirely in different climatic condition, India is also in different climatic conditions, Australia different. Then how come one particular organism live in all of this region? That is not possible. I just told you, be it plant or animal organism that will exist on the earth depends on the latitude. Okay, so looking at the today's present location of all of this continent, it is very difficult to explain. But if you go back in time and consider this continental drift theory, since all the continents were located in a same location, forming a supercontinent Pangaea, only then you will be able to explain. And in real, what happened is, in today's continental location, you see a very similar deposit happening in a very similar geological time period you found in India, you found in Africa, you find in South America, you find in Antarctica, you find in Australia. Now you look at the map. All these continents are in different location, different climatic condition, same deposit. How it will happen? The only explanation is, in the geological past, they were together at one particular place. Therefore, the presence of distributions of Permo-Carboniferous glaciation deposits or evidence found in Brazil Falkland Island, okay, or South America, this is in South America, in South Africa, Peninsular India and Australia. Presence of fossil remains of land animals and plants in different continents give a very strong evidence that yes, continental drift theory is real and continental drift theory is right. Okay, so these are the evidence in support of the continental drift theory. Is it clear? Yeah. If you have any doubt regarding any point, you can interrupt me at any time. Okay. The only point is, things should be very clear so that you remember the points with understanding. Not remembering for the sake of remembering by memorizing without understanding the concept clearly. If you do that, in exam you will forget, or you will have to spend a lot of time revising again and again. So one of the best efficient method is to remember via understanding. Okay. Therefore, I am telling you again, if you have any doubt in your mind, you can go ahead and ask me. Okay. Anyways, now, but there are some criticism of this continental drift theory. Criticism is very, very important. Okay. Just by understanding the basic concept, the picture is not complete. You see here, we have already discussed in our Unacademy platform. I have this answer writing session. There we have already discussed about the importance of directional word. Okay, directional word in the question. Directional word such as discuss or critically analyze, so on and so forth. If there is a question in exam regarding critically analyze continental drift theory, then you will have to provide the negative aspect also. Therefore, criticism is very, very important for all the topics it is not only applicable in geography, it is equally applicable to all of your other subjects also, be it in your GS, be it in your other subjects. Okay, anyways, criticism means the limitation of continental drift theory. What are the limitations? You remember, you see here, during this continental drift discussion just now, we seen two type of motion. That is, one is the northward movement of the continent. Example, the Indian plate, African plate move northward, and the other type of movement was the westward movement of North America, South America. Now, for the northward movement, we have seen it is because of the equatorial bulge and gravitational force of this equatorial bulge. But one of the criticism is, yes, because of the equatorial bulge, more mass there, so more gravitational force, yes, it is there, but that force is not adequate in order to pull such a huge landmass like Indian plate or like African plate. So the forces are hopelessly inadequate. That is one of the criticism of this continental drift theory. On the other hand, the westward shifting of the continent or the westward movement of the continent, such as the North America and South America, we consider the presence of this tidal wave. This tidal wave, when it hits the North and South America, it is shifted towards the west. But this also, yes, there is a tidal wave, but the forces are hopelessly inadequate in order to push such a huge landmass towards the west by the tidal force. So that is the force responsible is the main criticism of continental drift theory. You see here, very important one finer point that you need to know. In criticism, it is not criticizing the continental drift theory per se. It is just criticizing the forces that was assumed by Alfred Wegener. Clear? It is not criticizing the continental drift theory per se. They are just criticizing the forces that was considered by Alfred Wegener. Why? Because we are going to see plate tectonic theory also. There we will use, or in the plate tectonic theory, different type of force will come. Okay, so remember this. These are the finer details which you will not find in the book also, but you will have to interpret by yourself. Clear? The other important factor is Alfred Wegener considered, see, in the Swiss or in the interior of the earth, we all know that the Ciel, that is the lithosphere, it is floating over the Sema, that is the mantle, that is the asthenosphere. Okay, now Alfred Wegener considered this particular or accepted that the Ciel is floating over the Sema. Now, if it is floating over the Sema, you see here, in the North and South America region, you see, you have this Rocky Mountain system here. And in the South America, you have this Andes mountain system here. Now, Alfred Wegener accepted, okay, he accepted the theory that the Ciel, that is the lithosphere, is floating over the asthenosphere. Clear? Now, he accepted this and he said it is moving towards the west. Then the point is, this continental drift theory is not able to explain the formation of Rocky and Andes mountain. If it is floating, then it should float smoothly. Then why this formation of mountain? Because mountain will be formed only when there is a resistance that is offered and the folding that will take place. Because the mountain that you will find in the North America in the form of Rocky Mountain, it is a fall mountain. In the South America, you have this Andes mountain. This is also a fall mountain. It is just like accepting two diverse idea. If he is accepting that the Ciel is floating over the Sema, then how come this mountain come about in the North and South America? So this was not able to explain by continental drift theory. So it becomes the second criticism of this continental drift theory. Clear? I hope that is clear. Clear? we'll end the session here today. We will continue tomorrow with the convection current theory of Arthur Holmes, and subsequently we will go and see sea floor spreading. And after this sea floor spreading, we will gradually go into plate tectonics. Okay, that is how we will flow from one part to the other gradually. Okay. Anyway, thank you so much for your patience and cooperations. For all the topics that we are discussing here in the YouTube session, I conduct a answer writing session in Unacademy platform. It is completely free. You just have to download the Unacademy app. Okay, you can search by my name, that is SUNEP C Jamir, JAMIR. Okay, I conduct this session from 1 p.m. to 2 p.m. every day. Okay, so you can always come and join me there if you are interested. Okay, anyway, thank you so much for your patience and cooperations. We will meet again tomorrow at the same time. Okay, 11:30. Bye bye and take care.